Welcome to Lucid Mind Chemistry channel. In this video, I'll be solving Chemistry A-Levels multiple choice questions. Paper 12 from May-June 2022. For question timestamps and other useful information, please visit video description. Question 1. Equations involving 4 enthalpy changes are shown. We have different equations. Sodium gas goes to Na+, Na2+. Solid goes to gas, solid goes to gas along with electrons. Which equation represents the second ionization energy of sodium? Now, ionization energy is the energy that is required to remove an electron from outermost shell of an isolated gaseous atom. So in this one we can see gaseous atom is this one and this one. These are solids, so solid goes to gas. This is not ionization energy, it is the enthalpy change of atomization. While in this one solid goes to gas, again it is ionization energy along with the atomization, both are combined together. So we only need to find out the second ionization energy. Now for first ionization energy, 1 mole of electron is removed from 1 mole of gaseous atoms to form 1 mole of positive ions. So this is first ionization energy. Now looking at the second ionization energy, we can see if 1 more electron is removed from already an A positive, it will be second ionization energy. Now second ionization energy is not given. Again they have removed 2 electrons from neutral atom. So it means it includes both first ionization energy as well as second ionization energy. Now if we want to find out the value of second ionization energy, we will have to subtract X and W. So X minus W will be equal to the second ionization energy. In given answers, it will be C. Question 2. This question refers to isolated gaseous atoms in the ground state. In which atom are all electrons paired? We have to find out the electronic configuration in the outermost shell and see whether the electrons are paired or unpaired. For this, you must know about the atomic numbers. Let's look at the periodic table. For barium, we have 56 protons. For bromine, we have 35. For sulfur, we have 16. And for silicon, we have 14. Now let's do the electronic configurations. Now before barium is in second group of the periodic table. Before barium we have a noble gas. So we can start from that noble gas. We have xenon. Atomic number of xenon is 54. So 54 are already gone. After xenon we just need to write the electronic configuration 6s, as we have 6th period. For barium, so 54 plus 2, it will be 56. So there are 2 electrons in 6s. Now all electrons of noble gases are always paired, and this is 6s2. So 6s2, in 6s we have 2 electrons with opposite spin, so this is also paired. So answer could be A. For B, let's see, we have bromine. Now bromine is in 7th group of the periodic table. Before bromine we can see we have argon that has 18 protons. So we can start from this. Then after argon we have 4s2, 3d10 and 4p5. Now we can see these electrons are paired. In S we have 2 with opposite spin. In D we have 10 with 5 pairs of electrons. In P we have 5. P subshell contains 3 orbitals, px, py, pz. We have 5, 1, 2, 3, 4, 5. So we do have 1 unpaired electron. So it is not bromine. Let's do the same for sulfur. Sulfur is 16. And now we can start from neon. Neon is 10, and then we have 6 left. So we have 3s2, 3p4. Again in 3p we can see we have 4 electrons, so it should be 6 in order to complete all the pairs. 1 2 3 4, so we have 2 unpaired electrons. And similar thing for silicon is 14. Now we can use neon, and then again 3s2 and 3p2. So S has paired electrons while P has got 2 electrons that are unpaired, 1 2. So correct answer would be barium. Question 3. Which sample contains the most iodine? Now we have 1 gram of calcium iodide, 1 gram of potassium iodide, then sodium iodide, and similar for ammonium iodide. For mass of element in a compound, we need to find out the mass of iodine in each compound. For this one, we can use formula. So mass of element in any compound it is equal to the atomic mass of that element into number of atoms of that element divided by molecular mass of the whole compound multiplied by mass of compound. So we can input values for all of these, then we'll have our answer. Let's first find out the molecular masses. For calcium, we know from periodic table it is 40.1. And we have 2 iodine, so 2 into the atomic mass of iodine, which is 126.9. So for calcium iodide, the MR it is equal to 293.9. Similarly for Ki, we have 1 potassium, 1 iodine, so 39.1 plus 126.9. So the MR it is equal to 166. Similarly for sodium iodide, we have sodium which is 23 plus 126.9 for 1 iodine, so it is equal to 149.9. Last one is ammonium iodide. For nitrogen it is 14, for 4 hydrogen we have 4, for 1 iodine we have 126.9. so the molecular mass it comes equal to 144.9. Now we have the molecular masses and the atomic masses. Let's put the values. So mass of element, for this part we need to find out the mass of iodine. So it will be the mass of iodine. Let's do it for first one. So mass of iodine is equal to, atomic mass of iodine is 126.9. Number of atoms, let's see how many atoms are there in calcium iodide. We have 2. MR of the whole compound is 293.9 into the mass of compound which is given, so it is 1 gram. So mass of iodine in first one it comes equal to 0.86 grams. So this much iodine is present in part A. Similarly for part B, we can do mass of iodine it is equal to 126.9. Number of atoms is 1. MR of potassium iodide is 166. So it is equal to 0.76 grams. Similarly part C, mass of iodine it is equal to, we have sodium iodide, so 1 iodine 126.9 into 1 divided by 149.9 for NaI into 1 grams. So it is equal to 0.85 grams. Now let's do it for the last one. We have ammonium iodide. So 126.9, we have 1 iodine divided by the molecular mass, which is 126.9 into 1. So it will be equal to 0.87 grams. Now out of these four, we can see that highest mass is from part D. So therefore answer is 1 gram of ammonium iodide. Question 4. When a small sample of hydrocarbon Q is completely combusted, hydrocarbon means we only have carbon and hydrogen, it produces 3.52 grams of CO2 and 1.44 grams of water. What could be the structure of hydrocarbon Q? These four are given. Let's find out the number of carbons and hydrogens in each. So first one is in which we have 6 corners, so it means 6 carbons are there. With each carbon there is 1 hydrogen also present, because carbon makes 4 bonds. So the formula for A, it is C6H6. For B, we have 8 carbon atoms. So C8, and with each carbon we have 2 hydrogen atoms. So 16 hydrogen atoms. For part C, we have 4 carbons and 2 hydrogens, so the formula is C4H2. For part D, we have 1 hydrogen on this carbon, 1 on this, and 2 with the other carbons. So C6H10. Let's find out by the help of balanced equation. Now these are different formulas. We can just write C and N. We do not know how many carbons and hydrogens are there. So C and H. Now they are completely combusted in the presence of oxygen to form CO2 and H2O. Let's find the number of moles for CO2. Molecular mass is 44, so we can divide mass divided by mR to find out the number of moles of carbon dioxide. So it comes equal to 0.08 moles. We can do similar for water. We have 18 as molecular mass, so dividing mass by molecular mass, it comes equal to 0.08 moles. So number of moles is same. So if this is 0.08 moles, this one is 0.08 moles, what does it mean? It means that the molar ratio is 1 to 1. So we have 1 mole of carbon dioxide, we have 1 mole of water. Now in 1 mole of carbon dioxide we have single carbon, in 1 mole of H2O we have 2 hydrogen atoms. So we can say for each carbon there must be 2 hydrogen atoms in order to balance the equation. So if carbon is N, hydrogen should be double amount of that carbons. So if carbon is 6, hydrogen should be 12, A is wrong. If carbon is 8, hydrogen should be 16, so B seems to be correct one. Similarly, in C, hydrogen should be 8, in D, hydrogen should be 12. So the only one that is correct is part B. Question 5. Ethane and ethene are both hydrocarbon molecules. What is a feature of both molecules? What is ethane? Ethane is the one in which we have single bond between 2 carbon atoms and each carbon is making 4 bonds. So we have 6 hydrogen atoms. While ethene is the one again in which we have 2 carbon atoms, but in this one we have a double bond between the carbons, and with each carbon we have 2 hydrogen atoms. Now first part is the planar structure. We can see in ethane all single bonds are there, so each bond angle is 109.5, which is tetrahedral structure. So in tetrahedral, the atoms, they are not in one plane. While in this one, we can see each carbon is making 3 bonds, so the bond angle is 120 degrees each. And in this one, carbon is planar. So planar structure is only in ethene. Bond angle of 109, it is only in ethane. Then we have sigma covalent bonds and pi covalent bonds. In sigma covalent bonds, you can see all bonds in ethane are sigma. While in ethene we have sigma bonds, we also have a pi bond. So both, and pi bond is only present in ethene. So the thing that is correct for both of them is C. Question number 6. Elements J and L are both in group 15. J and L each form a gaseous covalent hydride in which their oxidation number is -3. In the liquefied form of these hydrides, significant hydrogen bonding occurs only in the hydride of L. Which row about J and L could be correct? You have to identify J, identify L, and find out the outer shell electronic configuration. Now group 15 means we have group 5. In group 5 we have 5 electrons in the outermost shell. Now the important point is this one, we have hydrogen bonding in L. Now for hydrogen bonding, it only occurs in fluorine, oxygen and nitrogen. So we have fluorine, oxygen, nitrogen. It means it could either be A or B because L contains nitrogen. So nitrogen is a part of group 5 of the periodic table. It has got 5 electrons in the outermost shell, and same thing is with arsenic. So let's see about arsenic. Now the atomic number of nitrogen is 7. We can do electronic configuration. It will be 1s2, 2s2 and 2p3. So we can see that the outermost shell electronic configuration is ns2 and np3 because collectively these two, they add up to 5 electrons in the outermost shell. As the principal quantum number 2 is same, so the electrons present should be added to find out the outermost electrons. So it should be s2 and p3. Let's confirm it for arsenic as well. So we have As. Atomic number is 33. Now we can start from the nearest noble gas. So we have argon 18. Then we have 3d10, 4s2 and 4p3. So again we have to add the electrons present. So 3 plus 2, it becomes 5. So the electronic configuration is still s2 and p3. So it is correct for both. So therefore correct answer is B. Question 7. Which gas will behave least like an ideal gas at 150 degrees centigrade and 101 kilopascals? Now we can rephrase this statement. Least likely an ideal gas means gas with most intermolecular forces. So we know among these four, ammonia, fluorine, krypton and steam, these two are noble gases, so they have minimum force of attraction between their atoms. So it is not B or C. It could be ammonia or steam. Now let's see among ammonia and water. Let's compare ammonia and water. In ammonia and water we have hydrogen bonding, but the boiling point or the intermolecular forces in ammonia are weak as compared to steam or water. In water we have strong intermolecular forces. Now both are present at 150 degrees centigrade and 101 kilopascal, so it means that we'll still take out the one in which the forces are stronger. So as forces was initially stronger in liquid water as compared to liquid ammonia, this force will still be stronger at high temperature and high pressure. So among ammonia and steam, the correct answer should be steam, because we have stronger hydrogen bonds, stronger intermolecular forces, and oxygen is more electronegative than nitrogen. Question 8. When an evacuated glass bulb of volume 200 cm3 is filled with a gas at 300 Kelvin and 101 kilopascals, the mass of bulb increases by 0.68 grams. The gas obeys the ideal gas equation. So this is a question including ideal gas. What is the identity of the gas? Now we can find the identity by calculating the molecular masses of the given gases. We have argon, krypton, neon, and nitrogen. Now looking at the periodic table, the atomic mass of argon is 39.9, for krypton it is 83.8, the atomic mass of neon is 20.2, for nitrogen as the formula is N2, so it is 14 into 2, it will become 28. So let's use ideal gas equation. We have PV equals nRT, where n is the number of moles, so we can rewrite the equation. PV is equal to number of moles is mass in grams divided by atomic mass or molecular mass. Now we have to find this atomic masses, so we can rearrange equation. AR will be equal to mass into R into T divided by P into V. Now putting values, we have different values. Mass in grams is given, it is 0.68. R is 8.31, it is constant. The value is given on the last page of this paper. Temperature is in Kelvin, so we have 300 for temperature. Now pressure should be in pascals. As it is kilopascals, so we can multiply it with 1000. So it will be 101 into 10 to the power 3. And volume should be in meter cube, so we can convert centimeter cube into meter cube by dividing 1000 and again by dividing 1000. So it is 2 times divided with 1000. Or instead you can write into 10 exponential minus 6. So this will give us the atomic mass. It comes equal to 83.92. So we can see it is closer to the part B. So correct answer should be krypton. Question 9. The standard enthalpy of formation of NO2 gas is 33.2 kilojoules per mole. Standard enthalpy of formation of N2O4 gas is 9.2 kilojoules per mole. What is the standard enthalpy change for the reaction NO2 converts to N2O4 gas? So we can calculate this using Hess's law. We have NO2 gas, N2O4 gas. There are 2 moles. Now formation, what is formation? When we have elements and that elements they combine together to form these compounds. So we can write elements. For this we need nitrogen and oxygen. Now let's draw arrows. These elements they can combine together to form this product NO2, or they can combine to form this product N2O4. So this will be enthalpy change of formation of NO2, as it is 2 moles, so 2 into del HF of NO2. For this side we have just 1 mole, so we can simply write the enthalpy change of formation of N2O4. Now this equation, it represents the enthalpy change of reaction, the thing that we have to find. Let's draw a cycle. For this one we know this is 2 steps and this is 1 step. So according to Hess's law, these two combine together to give out this. So we have enthalpy change of reaction plus 2 into enthalpy change of formation of NO2 it is equal to enthalpy change of formation of N2O4. Now we can rearrange. So del HR is equal to del HF N2O4 minus 2 into del HF NO2. Now we just have to put values from given question 33.2 and 9.2. So del HR will be 9.2 minus 2 into 33.2, or 9.2 minus 66.4, the value will be negative. So correct answer is then A. Question 10. Separate samples of 25 cm cube of 0.1 mole per decimeter cube sodium hydroxide aqueous are added to each of 3 different acids. Solutions as described. The temperature of each solution was 298 Kelvin before mixing. We have sulfuric acid, hydrochloric acid and ethanoic acid. These two are strong while this one is weak. The concentration is same, volume is same. Which statement describes the temperature rise that occurs on mixing each of these 3 acids separately with sodium hydroxide? Now, as concentration and volume is same, according to formula, number of moles is equal to concentration into volume in decimeter cube. The number of moles of all these 3 will be same. So let's just consider 1 mole of each. Now same volume of sodium hydroxide is added to each one. Part A, it says the temperature rise in all 3 mixture is the same. The temperature rise using sulfuric acid and HCl is same. The temperature rise using ethanoic acid is greater than using HCl, or the greatest temperature rise occurs using H2SO4. So the temperature rise, it all depends on the neutralization reaction. We know in neutralization reaction, acid alkali becomes salt and water. So let's see how many moles of water will be produced. It depends on how many H plus ions are released into the solution. So we have sulfuric acid, H2SO4. If we take 1 mole of H2SO4, it dissociates to produce 2 moles of H plus and 1 sulfate ion. While for HCl, if we have 1 mole of HCl, we can find out that it can produce only 1 mole of H plus and 1 mole of Cl negative. And for ethanoic acid, as it is weak acid, so it will still produce H plus, but the concentration will be less as compared to HCl. So among these 3, we can see that highest concentration of H plus is in sulfuric acid. So more H plus will react with OH negative to form water. So greater water molecules will be formed. More number of water molecules means higher energy or more temperature change. So the temperature rise in all mixtures should not be same. Sulfuric acid and HCl is not same because we have different moles of H plus. Temperature rise using ethanoic acid is greater. No, it is not greater because this is a weak acid. So correct answer seems to be part D. Question number 11. NCl3 reacts with water. They have given equation NCl3 plus 3 moles of water. It forms ammonia and 3 moles of HClO, which is perchloric acid. The oxidation state of nitrogen does not change in this reaction. Which statement is then correct? So you have to find out whether chlorine is reduced or oxidized, or hydrogen is oxidized or reduced, or whether it is not a redox reaction. Let's find out the oxidation states of each element. So for first one, we have nitrogen and 3 chlorine. Now nitrogen is more electronegative than chlorine, so therefore nitrogen will be negative and chlorine will be positive. So nitrogen is negative 3. 1 chlorine atom will be plus 1. Overall 3 chlorine will be plus 3, so it is balanced. In water, hydrogen is +1, oxygen is -2. In ammonia, nitrogen is more electronegative, so it is -3, and each hydrogen is +1. In HClO, again we have oxygen that is more electronegative than chlorine, so oxygen is negative and chlorine will be positive. So we have +1 for HCl, H, and +1 for Cl. Now we can see whether any change is occurring or not. So it says chlorine is reduced. Now we can see chlorine goes from +1 to +1. So there is no change. Chlorine is oxidized. No, there is no change. Hydrogen is both oxidized and reduced. Hydrogen, we can see it goes from +1 to +1 or +1. So there is no change. This is not a redox reaction. As you can see, there are no changes in oxidation state. So obviously it is not a redox reaction. Question 12. In which row do the oxidation numbers of vanadium increase? So we have to find out the increase. Let's find out which one are different. We have VO43 negative, VO3 negative, VO2 plus, VO2 positive, V2O3. Now this one is similar to the first one. This one is similar to this one. This is similar to this one. So I think that's it. VO2 positive, yes. So we have to find out the oxidation state in these 5, then we can find out in all of them. So let's do it one by one. First one is VO4 3 negative. So we have VO4 3 minus, 1 vanadium, 4 oxygens, overall charge is -3. So for oxygen it is -2, so it will be -8, or V will be +5. So VO4 3 negative is +5. Second one is VO3 minus. So 1 vanadium, 3 oxygens, and overall charge is -1. So V -6 equals -1, or V is +5. Okay, let's do it for VO2 positive now. So 1 vanadium, 2 oxygens, and overall charge is +1. So V -4 equals +1, or V will be +5. Now let's find out in VO2 plus. So 1 vanadium, 1 oxygen, overall charge is 2 plus. So V -2 equals 2 plus, or V is equal to 4 plus. Now one is left, which is V2O3. So 2 vanadium, 3 oxygens, overall charge is 0. So 2 vanadium will be equal to +6, while 1 vanadium will be +3. Now we can see in which the oxidation number increase. So +5 +5 +5, it is same. 4 3 5, 3 4 5, 5 5 4. So correct answer is then C. Question 13. A synthesis for methanol is shown. We have CO2 reacts with hydrogen to form methanol and water. Enthalpy change is negative as it is exothermic reaction. Which conditions would produce the greatest yield of methanol at equilibrium? You have to find out the values of pressure and temperature. First thing is pressure. Now for pressure we have to find out which one is gas. So we have CO2, we have hydrogen, these two are gases. So if pressure is high, the gas molecules, we have 4 moles of gas on reactant side, and we have liquid methanol and water which is also liquid on the product side. So when pressure is increased, the equilibrium shifts from more number of moles of gas to less number of moles. So it will move in forward direction and we will have more amount or more yield of methanol. So pressure should be high. Second thing is temperature, should it be 80 or 20. So now as the reaction is exothermic, for exothermic reaction we know if temperature is increased, as heat is the product, you are increasing heat, so when product is increased the reaction goes in backward direction. So at higher temperature there will be less yield of methanol, while at lower temperature there could be more yield. So temperature should be less, not more. Correct answer is therefore B. Question number 14. Hydrogen and iodine can react reversibly to produce hydrogen iodide. The equation is shown. 1 mole of hydrogen reacts with 1 mole of iodine to form 2 moles of hydrogen iodide gas. 4 moles of hydrogen gas and X moles of iodine vapors are mixed in a sealed container of volume 1 decimeter cube at a temperature of 460 Kelvin. System is allowed to reach equilibrium. The equilibrium mixture contains 2 moles of hydrogen iodide. The equilibrium constant Kc for the reaction is given as 4.0. What is the value of X? Now they have given hydrogen iodine equation. All are in gases and we have number of moles, we have volume. So now we can see initially they have given 4 moles of hydrogen gas and X moles of iodine vapors. So let's write initial. We have 4 moles of hydrogen gas and X moles of iodine vapors. And initially the amount of product formed is 0 because the reaction has not started yet. Then after a while there will be some change in the concentration, the reactants will decrease, the product will increase, and then after change there will be equilibrium. Now let's see what have they given at equilibrium. It says that the equilibrium mixture contains 2 moles of hydrogen iodide. So we have 2 moles of hydrogen iodide at equilibrium. Now we can see according to balanced chemical equation, 1 mole of hydrogen reacts with 1 mole of iodine to form 2 moles of hydrogen iodide. So the number of moles of reactant is half of that of number of moles of product. So if we have 2 moles of hydrogen iodide that is produced, now we can see the change. It means that we have a change of plus 2. 0 plus 2 becomes 2. And now change as the ratio of moles is 1, ratio 1, ratio 2. So the change will be relative. For 2 moles the change is 2, for 1 mole the change should be 1. So it is minus 1. Similarly, for 2 moles the change is 2, for 1 mole the change should be 1. Now the reactant is, the change of reactants is minus 1 because reactants decrease and product always increases. So now at equilibrium we can see we have 4 minus 1, it will be equal to 3 moles. So 3 moles will be at equilibrium for hydrogen. X minus 1, we do not know the value of X, so we can write X minus 1. And we have 2 of hydrogen iodide. Now we can use the formula for Kc. Kc is the concentration of product to the concentration of reactants. In this case the product is hydrogen iodide, so we have the concentration of iodide raised to the power its number of moles, concentration of hydrogen raised to the power its number of moles, similarly for iodine. Now as in the question they have given volume as 1 decimeter cube, so concentration is equal to moles divided by volume. So if anything divided by 1 is always the same, so it means we can take number of moles as concentration. There will be no difference. So number of moles at equilibrium is 2. So we can write 2 instead of hydrogen iodide. So it will be 2 square divided by 3 into x minus 1. Now we can do this one. We have 4, we have 3x minus 3. The value of Kc is given in question. The value of Kc is 4. So now we can equate it with 4. So now we can say 4 is equal to 4 divided by 3x minus 3. Or 4 into 3x minus 3 equals 4. So it will be 12x minus 12. Or 12x equals to 4 plus 12, which is 16. So x equals 16 divided by 12. So it comes equal to 1.33. It means 1.33 moles of X were present initially. So the value of X is calculated. It is 1.33. Answer is therefore C. Question 15. A large amount of N2O gas. We have a large amount decomposes into nitrogen gas and oxygen gas in the presence of tiny amount of gold foil catalyst. The gold foil provides a solid surface on which the catalyzed reaction takes place. The graph shows the concentration of N2O gas against time. On y-axis we have the concentration of N2O, on x-axis we have time for decomposition. The graph is a straight line. Which row describes the change in rate of reaction as N2O gas decomposes from 0 to 10 minutes? The effect of adding more gold foil catalyst on the rate of decomposition of the same amount and concentration of N2O. So for this question you need to understand the function of this catalyst. We have a very tiny amount of catalyst. So let's suppose if we have 1000 molecules of N2O gas, which is a very large amount, and only 10 molecules can fit on the surface of this tiny catalyst. So what will happen? Actually the limiting reagent is the solid surface. It is not the concentration of N2O gas. So now we can see the concentration of N2O, it decreases constantly. It means that the decomposition is constant. N2O gas, it goes to nitrogen and oxygen. So what would be the change in rate of reaction? There will be no change in rate of reaction because the rate of reaction is constant. So the change in rate of reaction is 0. So we can say no change because as surface area is limited. And from graph we can also see there is a constant decrease. So it means the change in rate is 0. Second thing, the effect of adding more gold foil catalyst. What happens if we add more catalyst on rate of decomposition? So if you are going to add more catalyst, so you are basically increasing the surface area. So instead of 10 molecules, it might become 100 molecules. So when number of molecules decomposed will be greater, so what will happen to the rate? The rate will definitely increase. So let's look at the answers. It says change in rate of reaction as N2O gas decomposes. So there is no change as we already discussed. And the effect of adding more gold foil will increase the rate of decomposition because the surface area will be greater and more molecules will be decomposed. So answer is A. Question 16. The Haber's process for manufacture of ammonia is represented by the equation shown. We have this equation: nitrogen gas, hydrogen gas forms ammonia. Reaction is exothermic as enthalpy change is negative. Which statement is correct about this reaction when temperature is increased? Now this is exothermic reaction. A. Both forward and backward rate increases. Now they are asking about the rate of reaction. What is the rate of reaction? Rate of reaction depends on the intermolecular collisions. So when temperature increases, the collisions increase. So if collisions increase, then obviously the rate of reaction will also increase. So the reaction rate should increase in forward direction. It should also increase in backward direction, because the temperature, it affects all the molecules, not the specific ones. So part A seems to be correct. Then part B, the backward rate only increases. Now this is wrong, because the rate increases in both directions, not backward, neither, only forward. There is no effect on the backward or forward rates. Again, this is incorrect, because temperature changes the rate of reaction. So correct answer is then A. Question 17. Ammonia aqueous is added to separate samples of sodium chloride aqueous, magnesium chloride aqueous, barium chloride aqueous, and silicon chloride liquid. Under the conditions of this experiment, only 2 samples will produce a white precipitate when ammonia is added. What are these 2 samples? So we have to find out which one makes a precipitates with ammonia aqueous. Now what is ammonia aqueous? When ammonia is dissolved in water, what happens? It reacts with water molecules to form ammonium ions and hydroxide ions. So basically we are concerned with this hydroxide, because it can react to form a precipitate. Let's see what happens with sodium chloride. Sodium chloride can react with OH to form NaOH. So Na positive and OH negative, they can form sodium hydroxide, which is not a precipitate because it is soluble. All compounds of sodium are soluble. So then we have magnesium, Mg2+. It can react with hydroxide present. So it will form magnesium hydroxide. Now magnesium hydroxide is relatively insoluble, so it is a white precipitate. Third one is barium chloride. Let's look at that. We have barium 2+. It can react with hydroxide to form barium hydroxide. Now down the group, the solubility of hydroxide increases, so therefore barium hydroxide is soluble. It is not a precipitate. Then we have silicon chloride in the last, so SiCl4. Silicon chloride, it can react with OH negative to form silicon dioxide and release HCl gas. So now this silicon dioxide that is formed, it is a white precipitate. So SiCl4 and MgCl2, they form white precipitates, so we can find out them. We have MgCl2 and SiCl4. Correct answer is therefore B. Question 18. Why is the ionic radius of a sulfide ion larger than the ionic radius of potassium ion? So let's see, what do they mean? We have potassium, we have sulfur. The atomic number of sulfur is 16. And sulfur has gained 2 electrons because it is in 6th group of the periodic table, so it will become sulfur 2 negative. For potassium, we know the atomic number of potassium is 19. As it belongs to group 1 of the periodic table, so it will lose 1 electron in order to complete its outermost shell. So sulfur has gained and potassium has lost. Now it says sulfide ion is larger than potassium. So what's the reason? Let's see. Part A, ionic radius always decreases with increasing atomic number. Now we know along the period what happens, the atomic number increases and atomic size decreases. This is because number of shells remains constant. But down the group, atomic number increases and size also increases. So this is only true for period. Part B, positive ions always have smaller radii than negative ions. Now this statement is true if you have similar atom. Same atom, if it makes a positive ion and a negative ion, the negative ion will be larger as compared to positive ion. But not true for different atoms. So they haven't specified, so this might be wrong. Part C, the potassium ion has more protons in its nucleus than the sulfide ion. We can see potassium ion has got 19 protons while sulfide has got 16 protons. So what happens with the proton number? Now we have 19 protons and 18 electrons and 16 protons and 18 electrons. So the force of attraction between 19 protons and 18 electrons will be more as compared to the other one. So therefore potassium ion will be less in size or smaller in size as compared to sulfide. So this seems to be true. Then we have the sulfide ion is doubly charged, the potassium ion is singly charged. Now this could be the reason if the charges were same. Now we have opposite charges. Actually sulfide is 2 negative and potassium is +1, so the effect is totally inverse of each other. So therefore this statement does not explain anything. The correct answer is then C. Question number 19. Which graph correctly shows relative electronegativity plotted against relative atomic radius? So we have electronegativity, we have atomic radius. For element sodium, magnesium, aluminum, silicon, so they are asking about the period 3 elements. Now let's look at electronegativity. Electronegativity of a substance, it is directly proportional to the number of protons. So greater the number of protons, greater will be electronegativity. And also electronegativity is inversely proportional to size of atom. So smaller size means greater electronegativity. So in period 3, as we move along the period in periodic table, the atomic size decreases, electronegativity increases. As they have given these in sequence, we can see sodium is 11, magnesium is 12, aluminum is 13, silicon is 14. So now as number of protons increase, the number of electrons also increase, number of shells remains constant, so atomic size will decrease because of the stronger forces between protons and electrons. Electronegativity is dependent on size, so as size decreases, so electronegativity will increase. So on y-axis we have electronegativity, so it should be highest for silicon, it should be lowest for sodium. So sodium, then magnesium, then aluminum, then silicon. So electronegativity trend is correct as it increases like this. Then we have atomic radius, so the highest atomic radius is for sodium, then decreases for magnesium, aluminum and silicon. So again atomic radius is highest for sodium and smallest for silicon. Atomic radius increases in this way. So A seems to be correct for both options. Question 20. The table gives information about calcium carbonate and calcium hydroxide. Which row is correct? First one is that calcium carbonate is more soluble in water than calcium hydroxide. Second part is that calcium hydroxide can be manufactured using calcium carbonate as starting material. Now for calcium carbonate, if we add calcium carbonate to water, what happens? It converts into calcium hydroxide and releases CO2 gas. So yes, calcium hydroxide can be manufactured from this calcium carbonate as a starting material, so it should be a yes. While second thing is the solubility. Now the solubility of calcium hydroxide is similar to the solubility of calcium carbonate. This is because calcium carbonate produces calcium hydroxide, so they are interdependent. So calcium carbonate is more soluble in water than calcium hydroxide. This cannot be true. Both are actually dependent on each other, so therefore the solubility should be same. So correct answer seems to be B. Question 21. Q is a group 2 metal. An excess of carbonate of Q is added to sulfuric acid followed by filtration. A sample of Q sulfate is then obtained by evaporation of the filtrate. What could be the identity of Q? Okay, now they have said that sample of sulfate is then obtained by evaporation of the filtrate. Now this statement means that sulfate is soluble. Now it says carbonate is added to sulfuric acid. So let's add carbonate to sulfuric acid and let's see what does it make. So we have metal carbonate of group 2, sulfuric acid. So acid plus carbonate, it forms salt. So it will be metal sulfate, salt plus water plus CO2. Now looking at sulfates of group 2, we know that solubility of sulfate decreases down the group. So we have barium sulfate in the end of group 2 or at the bottom. So barium sulfate is the least soluble one. So it should be solid and it can be filtered off. While calcium or magnesium sulfate, they are soluble. Let's see what could be the identity of Q. As in the question, it says Q sulfate is obtained by evaporation of filtrates. So it means Q sulfate is soluble. So it cannot be barium sulfate because barium sulfate is insoluble. C is calcium only and D is calcium or magnesium only. Now we know calcium sulfate is soluble. Magnesium sulfate is also soluble. So it is true for both of them. Not only calcium but magnesium is also true. So correct answer should be D. Question 22. X, Y and Z are three elements in group 17 which is halogens. X2 has weaker covalent bonds than Y2. Let's see, in halogens we have fluorine, chlorine, bromine and iodine. Now fluorine has the strongest bonds. So it says X2 has weaker covalent bonds than Y2. It means X2 is below and Y2 should be above. So we can write Y2 and X2. Second point, X2 has stronger instantaneous dipole induced dipole forces between its molecules than Z2. Now instantaneous dipole induced dipole forces, they depend on size of molecule. Greater size of molecule means stronger would be these forces. So it says X2 has stronger instantaneous dipole as compared to Z2. It means X2 should be below as compared to Z2 because down the group size increases. So if X2 is below Z2, then Z2 should be above X2. Then point 3, it says Y2 is a stronger oxidizing agent than Z2. Now what does stronger oxidizing agent mean? It means that Y can displace Z. So the one that is above is more active as compared to the one that is below. So Y can displace Z. So this sequence seems to be correct. So it says we have Y, Z and X. So Y should be above Z and Z should be above X. So X is the one that is below. So X could be iodine. Then we have Z above X. So above X we can have bromine or chlorine. And then Y, if we have chlorine then it should be fluorine. If we have bromine then it should be chlorine. So yes, this sequence seems to be correct. Now it means Y is chlorine, then Z is bromine and X is iodine. So correct answer is then D. Question 23. Chlorine reacts with aqueous sodium hydroxide forming two chlorine containing products. Which row shows the oxidation states of chlorine in the products under the conditions stated? So we have cold sodium hydroxide, we have hot sodium hydroxide. Let's see what is the product that is formed. So chlorine, when it reacts with sodium hydroxide, that is gold, it forms sodium chloride. This is one of the chlorine containing products. Second one is NaClO. And if sodium hydroxide hot is reacted, then we have NaCl and NaClO3. So let's find the oxidation states of chlorine in products. With gold sodium hydroxide we have -1 +1. With hot again we have -1 +1. So one of them is -1. Now in the second one we have one sodium, one chlorine, one oxygen. As oxygen is -2, sodium is +1. So in order to balance negative charges and positive charges, chlorine must be +1. So we should have +1 and -1 in cold sodium hydroxide. They have given +3, which is incorrect, and +5 is also wrong. Now let's look at the oxidation states in NaClO3. We have 3 oxygen atoms, so -6 for 3 oxygens. We have +1. So in order to balance negative and positive charges, chlorine must be +5. So now we have -1 and +5 for hot. -1 and +5. Correct answer is therefore D. Question 24. A catalytic converter reduces the amount of pollutants in the fumes of a car exhaust. Which row identifies a pollutant and shows how it is removed by the action of the catalyst? Now let's see first which one is pollutant among these 4 that are given. So we have carbon dioxide. Carbon dioxide is not a pollutant. It is a greenhouse gas. Carbon monoxide is a pollutant. Oxides of nitrogen, they are also pollutants. Unburnt hydrocarbons is also not a pollutant. It also affects greenhouse. Now we can see the chemical removal. Carbon monoxide, it should be oxidized to carbon dioxide. And oxides of nitrogen, they are also changed to or reduced to nitrogen, not oxidized to nitric acid, because we do not need nitric acid in our atmosphere. They are actually converted to nitrogen gas. So now we can see that B is the correct one. Question 25. Solid R is added to a solution of ammonium nitrate and mixture is heated. A gas is given off which turns red litmus to blue. What could be R? Now first thing is the litmus test. So we have red litmus to blue. It means that the gas is basic, because base turns red litmus to blue. Now as we have ammonium nitrate, so that basic gas could be ammonia. Now how ammonia is released from ammonium nitrate? So you should know that whenever you have ammonium salt, and it is reacted with any base, it will form ammonia gas. Ammonia gas will be released. So let's see which one is a base among these 4, because we do have ammonium salt. What we need is a base. So aluminum chloride, it is AlCl3, and this one is acidic in nature. It is not a base. Then we have magnesium chloride. Magnesium chloride is slightly acidic. Then we have sodium oxide. Now metal oxide, sodium belongs to group 1 of the periodic table. So this one is basic oxide. Last one is phosphorus oxide. Phosphorus is a non-metal, so non-metal oxides are acidic in nature. So the only one that is basic among these four is sodium oxide. We can write equation for ammonium nitrate. It is NH4NO3 plus this base, which is sodium oxide. We can have a salt, sodium nitrate. We can have ammonia gas along with the production of water. Question 26, a skeletal formula is shown. We have the skeletal formula. What is the total number of stereoisomers, including the one that is shown? Now this stereoisomers, it could be chiral centers, the optical isomers, or it could be cis-trans isomers. Let's see whether we have a chiral carbon here or not. So let's look into these carbons. The carbon that is connected to 4 different groups must be chiral. So let's look at this carbon. It is attached to one of the hydrogen atoms. So all 4 groups are different. 1, 2, 3, 4. So yes, this carbon is chiral. So we have one chiral carbon. Then these carbons are making double bond carbon are never chiral. Then we have this carbon. This carbon is actually attached to 2 similar groups. Both are CH3, so therefore this is not chiral. So we only have one chiral carbon that is present. So chiral carbon produces 2 isomers that are mirror images of each other. One is called dextro, second is called levo. Okay, now let's look at the cis-trans isomers. So for cis-trans we need a double bonded carbon. And that double bonded carbon must be attached to 2 different groups. These 2 are same, so therefore this will not form cis-trans. Now looking at this carbon, it is attached to a hydrogen atom and this whole group. So yes, both are different. This carbon is attached to a hydrogen atom and whole this group. So this is also different. So this will show cis-trans. Again, this carbon atom is attached to a hydrogen and this whole group. This one is attached to a hydrogen atom and this whole group. So this will also show cis-trans. So we have 2 cis-trans isomers, we have 1 optical isomer. So let's see the cis-trans in both cases. It could be cis-cis or cis-trans. One could be cis, the other one could be trans. Or we have the first one as trans, second one as cis, or both could be trans. So 4 possibilities are for dextrorotatory, in which we have one mirror image of this chiral carbon. Similarly, 4 will be for levorotatory, which are similar. So for levorotatory, again we have cis-cis or cis-trans or trans-cis or trans-trans. So in total we have 4 on one side, 4 on the other side. And this text is dextrorotatory, it is with each one of them. It is not separated, it is with them actually. So in total we have 8 that are formed. There is also a formula that you can use, 2 raised to the power n, where n is the number of double bonds or chiral centers. So we have 2 cis-trans double bonds, 1 chiral center. So in total we have 3, 2 power 3 is 8. So correct answer is C. Question 27. The molecular formula CH3 can represent an anion, cation or a free radical. Species with the molecular formula CH3 can act as an electrophile, free radical or nucleophile, depending on the number of outer shell electrons on the central carbon atom. How many outer electrons on the central carbon atom must be present for CH3 to act in these different ways? It should be an electrophile, a free radical or a nucleophile. Now, electrophile is something that is electron deficient or electron loving. Free radical is something that has unpaired electron present. And then we have nucleophile. Nucleophile is something that has extra electrons, so it is electron rich. So let's see how CH3 can act as an electrophile, a free radical, or a nucleophile. We can draw the structures. So we have carbon atom. Carbon atom has got 4 electrons in the outermost shell. As we have 3 hydrogen atoms, so 3 bonds will be with 3 hydrogens. 1, 2, 3. Now in total we can see we have 1, 2, 3, 4, 5, 6, 7 electrons present in the outermost shell, and if this is neutral, then this shows odd number of electrons and it is a free radical because we have an unpaired electron. So let's see how many electrons are there. There are 7 electrons in free radical, so it should be 7. Second thing is electrophile and nucleophile. We can remove 1 electron to make a nucleophile. We can add 1 electron to make an electrophile. So let's draw the structures as well. If we have carbon and we have just 3 electrons, 1 electron is lost or removed. So by removing, the charge is now positive. So CH3 positive is a electrophile because it is electron deficient. So in electrophile we have 6 electrons present in the outermost shell. So answer should be A. Now let's look at nucleophile. Nucleophile is the one in which we have 1 extra electron. Due to extra electron, the charge is negative, and this is an extra electron. So we have 8 electrons present in the outermost shell, so there must be 8. Correct answer is therefore A. Question 28. Compound Z, we have C7H13Br has 2 chiral centers. A sample of Z contains all 4 possible optical isomers. This sample of Z reacts with hot ethanolic sodium hydroxide to produce a mixture of only 3 isomers. 2 of these isomers are optical isomers of each other, and then 1 will be left. What could be the formula of Z? So we have to look out for 7 carbons, 1 bromine and 13 hydrogens. So in each of them we have 7 carbons, 1 bromine, 7 carbon, 1 bromine, 7 carbons and 1 bromine. So all of them have 7 carbons, 1 bromine, so hydrogen atoms should also be 13. So let's see which one has got 2 chiral centers. Now chiral center means the carbon that is attached to 4 different groups. So this carbon is chiral as it is attached to 1 hydrogen atom, and these 2 sides, they are different. This bromine is different, so this part is chiral. Looking at this carbon atom, it is also attached to a hydrogen atom, a CH3 group. This part and this part there that are different, so we have 2 chiral centers. Similarly, we can see this carbon is chiral as 1 hydrogen, and left and right side are different. This one is also chiral, left and right sides are different, 1 CH3, 1 hydrogen. In this one, this carbon is chiral. We have 3, 2, so different sides, 1 hydrogen atom. And looking at this carbon, it is also chiral. So this carbon is not chiral because it is attached to 2 similar groups which are CH3. And this carbon is attached to a bromine atom, a hydrogen atom. Left side and right side are different. Similarly, this carbon is chiral. These 2 sides are different, and we have a hydrogen and CH3. So all of them have got 2 chiral centers. Now next part, it says it reacts with hot ethanolic sodium hydroxide. So what hot ethanolic sodium hydroxide does is that it causes elimination. And in this elimination of halogenoalkane, a halogen is removed along with a hydrogen atom. So hydrogen atom must be adjacent on the adjacent carbon as that of halogen, and alkene is formed. Now let's see, we have this carbon that is attached to bromine. This carbon is attached to one hydrogen atom. So let's see what happens if I remove this hydrogen along with this bromine. So there will be a double bond here. The product will be like this. We have a double bond. Now we still have this carbon that is chiral. So it will form two isomers, two optical isomers 1 and 2. The cis trans is not formed because it is a cyclic structure. So in cyclic structure, cis trans is not possible. Now we have two isomers. What happens if I remove bromine along with hydrogen atom from this carbon? Then the double bond, it will be between these two carbons. So the structure will be like this. Now we have double bond between these two carbon atoms, and now this carbon is not chiral anymore because it is making a double bond. So in total we have 1, 2 and 3 isomers, out of which 2 isomers are optical isomers. So 2 optical and 1 simple. In the question it says it produces a mixture of 3 isomers, 2 must be optical and the other one should be something else. So A seems to be correct one. Then let's look at B. So with this carbon having a bromine atom, I can remove hydrogen atom from left side, which is this hydrogen, or from right side, which is this hydrogen. So both products will be like this. If I remove this hydrogen, then double bond is going to be between these two carbons. Now this carbon is still chiral. So two optical isomers are formed. Then if I shift to remove this hydrogen with this bromine, then the product formed could be like this. We still have a chiral carbon. So two optical isomers will be formed. In total we have now 4 optical isomers. So B is incorrect as we need just 3. Now let's move towards C. In C we have bromine atom on this carbon. A hydrogen atom can be removed from this carbon which is adjacent, from this carbon which is adjacent, or from this carbon. So there are 3 possibilities. Let's look into those. So first I'm gonna remove this hydrogen. So let's see, the product formed will be like this. So there is a double bond between these two carbons. This carbon is chiral, so we have 2 optical isomers, 1, 2. Now in second one, I'm going to remove hydrogen atom from this side. So now double bond comes here. This chiral carbon is not no more chiral because it is making a double bond, but this carbon is still a chiral. So 2 more isomers are present. So in total we have 4 now, which is already more than 3. So C is incorrect. There will also be a possibilities of 2 more. So it will make 6 in total. Now let's move towards D. We can see we have bromine atom on this carbon. And this carbon does not have any hydrogen atoms, so we cannot make a double bond between these two. Only this carbon contains a hydrogen atom. So let's remove these two. The product will be like this. And there will be a double bond. Now this carbon is not chiral anymore because it is making a double bond. So we only have this one product that is possible. So only one isomer is present. So among A, B, C and D, only A can make 3, out of which 2 are optical. Question 29. The free radical substitution reaction between methane and chlorine involves initiation, propagation and termination stages. Which row is correct? You have to find out what is involved in initiation stage and what is the radical produced that is in a propagation stage. So let's see whether it is homolytic or heterolytic fission. Homolytic fission means in which we have equal distribution of electron upon bond breaking, while in heterolytic we have unequal distribution of bonded electrons. So in first stage what happens? The chlorine Cl bonds, it breaks and we have two radicals that are formed. So we have equal distribution of electrons, bonded electrons between two chlorine atoms, so it should be homolytic. So homolytic fission take place. Then it says what happens in propagation. So this chlorine atom, it can react with methane. So now we have methane CH4. It can react with chlorine free radical. Now it will form CH3 radical and HCl is lost. So in propagation step, CH3 radical is formed. Okay, so correct answer should be B. Question number 30. The alkene shown reacts with an excess of HBr via an electrophilic addition reaction. What is the major product formed? Now we have alkenes, and in this alkene HBr is added. So according to the rule, we know that the major product is formed when hydrogen atom from HBr, it is attached to the double bonded carbon having more hydrogen atoms. And Br will be attached to the other carbon. So let's see which carbon has got more hydrogen atoms. So we have this carbon which has 0 hydrogens, and this carbon has got 1 hydrogen. So incoming hydrogen is going to be on this carbon and Br will be attached to this carbon. So in second double bond we can see this carbon is attached to 1 hydrogen atom while this carbon is attached to 2 hydrogen atoms. So incoming hydrogen will be attached to this carbon and bromine will be attached to that carbon. So let's draw the product that is possible upon addition. We have this structure. Now when HBr is added, double bond converts to single bond. Now this carbon will add a hydrogen atom to this one. So there will be a hydrogen atom, and with this carbon there will be a bromine. I'm not drawing other hydrogen atoms because a carbon makes 4 bonds, so there is also another hydrogen atom still present. So with this carbon we have a bromine, while with this carbon we have a hydrogen atom. So bromine is attached here and hydrogen is gonna get attached here. So then it will be the major product. Now let's find out the name. What is the name of this compound? So let's see what is in long chain. So we have 1, 2, 3, 4, 5, 6 carbon atoms that are present in long chain. Now numbering will start from that and from which the number of substituents is more and nearer. So we have bromine on second carbon, we have a CH3 on second carbon. So numbering should start from this portion. So 1, 2, 3, 4, 5, 6. So it is hexane. All of them show hexane. On second carbon we have bromine and CH3. On fifth carbon we also have a bromine atom. So it is 2,5-dibromo. 2,5-dibromo. We also have a methyl group on second carbon. So it is 2-methyl. And in long chain we have 6 carbons. So it is hexane. So correct answer should be B. Question 31. The diagram shows the structures of two halogenoalkanes. We have P and Q. Both compounds can be hydrolyzed. Which row is correct? You have to find out the compound that is more readily hydrolyzed and what should be the reaction mechanism. Now hydrolysis is the one in which OH, it replaces Br or F. So let's see, we have carbon bromine bond in one, we have carbon fluorine bond in the other. So In order to break carbon-fluorine bond, 467 kilojoules per mole energy is required, while in order to break carbon-bromine bond, 290 kilojoules is required. This is because fluorine is more electronegative and it makes a strong bond because of smaller size. So carbon-bromine bond is easy to break, so P hydrolysis will be fast and Q hydrolysis will be slow. So it should be P that is readily hydrolyzed. Now let's look at the reaction mechanism. Reaction mechanism depends on whether it is primary or tertiary halogenoalkane. So let's look at this carbon that is attached to bromine. Now the carbon attached to bromine is attached to 3 other carbons directly. So it means it is tertiary halogenoalkane. Tertiary halogenoalkane always undergoes SN1 mechanism. And let's look at this one. This carbon is attached, the carbon that is attached to fluorine, it is directly attached to 3 other carbon atoms. So this is also tertiary. So again SN1 mechanism should be followed. So we have SN1 instead of SN2 and the correct answer should be A. Question 32. The structure of chlorine is shown. This is the structure. Chlorine can be synthesized by reacting ammonia with a dibromo compound X. Now NH3 reacts with dibromo compound to form chlorine and releases 2 HBr molecules. What is the compound X? You have to find out the structure or the name of compound X. That is the reactant that forms this product. So let's see what happens here. We have NH3, we have 2 HBr that is lost. We have 2 bromine atoms with X. So we can say that compound X, let's suppose it is C8H16. It contains 2 Br and ammonia. Ammonia contains 3 hydrogen atoms. Now what can happen is this, that a hydrogen atom, it is lost with bromine and nitrogen makes a bond with one of the carbon atom. So one HBr is lost. Similarly, another hydrogen atom goes with bromine to form second HBr. So another bond is formed between nitrogen and the carbon atom containing bromine. Let's look at the structure where nitrogen is making 2 bonds with carbon atoms. So one is this bond and one is this bond. It means initially there was a hydrogen atom on this side and on this side, and this was the chain of carbons. So now we can separate both reactants. We have NH3 and H3, and we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So we had CH3, CH2, 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 this one is CH2, so these two are the reactants. A hydrogen atom goes with a bromine atom, so it means instead of CH3 there was one bromine attached. So I can write a bromine with this and that. So we have one bromine with this one bromine with this one. Now bromine and hydrogen, it is gone in form of HBr, and a new bond is formed between nitrogen and this carbon, which is this. Another bond is formed between these two. So this is basically the structure of X that contained 2 bromine atoms. So let's see. We have the names and the structures. Let's first draw the structures. We have bromine, then CH2, a bromine and CH2. Then we have 1, 2, 3 more CH2s. Then we had a CH and bromine. So this is the compound X. We have 8 carbons, we have 2 bromine and 16 hydrogen atoms. Now let's name this compound. We have 1, 5, 1, 5 dibromo and octane. So it is 1, 5 dibromo octane. There is no cycle in this one, so therefore it cannot be cyclo. Now we have to find out the formula. Let's write down the formula. We can group similar types of atoms. So we have CH2, 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 3 CH2s, so we can group them together. So I can rewrite this. We have a bromine atom. Then I have 1, 2, 3, 4 CH2s. Then I have a CH with bromine. And 1, 2 CH2s. And then a CH3. So this is the structure of compound X. And we can see this one is similar to the one given in part D. So therefore D is the answer. Question 33. Primary alcohols can be oxidized to aldehydes using either acidified potassium dichromate 6 or acidified potassium manganate 7. Both are oxidizing agents. The reaction mixture changes color as the oxidizing agent is reduced. What are the color changes that are seen? You have to find out the color changes in potassium dichromate 6 and potassium manganate 7. Let's first write down the formulas. We have potassium dichromate K2 Cr2 7. Potassium manganate 7 is KMnO4. The oxidation state of chromium before and after oxidation is, we can see we have 7 oxygen, so it is -14. We have 2 potassium, so it is +2. In order to balance negative and positive charges, chromium must be +12. So if 2 chromium are +12, then 1 chromium should be +6. So this is before oxidation. When this oxidizing agent, it oxidizes the other one itself, it gets reduced. So chromium +6 goes to chromium +3. So that is reduction of this one. The color of chromium +6 is orange, while the color of chromium 3+ is green. So it goes from orange to green. Let's do the same for the second one. We have KMnO4. 4 oxygens means -8. We have +1 for 1 potassium. So to balance charges, it must be +7. So Mn goes from +7 to +2 after reduction. The other substance is oxidized, while oxidizing agent itself gets reduced. So now let's see the color changes. Mn in +7 is purple, while Mn in +2 is colorless. So it goes from purple to colorless. So correct answer is then C. Question 34. Which reaction has a product that gives a yellow precipitate when treated with alkaline aqueous iodine? Now for yellow precipitate, there must be a CH3 group present in the reactant, and there are two possibilities of types of reactants. It can either be a secondary alcohol, or it can be an aldehyde or a ketone having CH3 directly attached to carbonyl carbon. If CH3 is directly attached to carbon having OH in secondary alcohol or this one, then only a yellow precipitate is formed as a product. So let's see which reaction produces this as a product. The first one, it says 2-chloropropane is warmed with dilute aqueous solution of sodium hydroxide. So now what will happen in this one? In this one, we have an aqueous solution of sodium hydroxide, OH, it will replace the chlorine. So this is a substitution reactions. Now I can draw the structures. So part A, We have propane that contains 3 carbons. We have 2 chloro, so on second carbon we have a chlorine atom. Rest of the number of hydrogens, CH3, CH, CH3. And we have aqueous sodium hydroxide that will form OH negative, which are going to replace this Cl. So the product is CH3, CH, and instead of Cl now we have OH plus NaCl. Now we can see that we have the thing that is needed for alkaline aqueous iodine test. So if CH3 is attached to CH having OH, then it can give positive result. So A seems to be correct one. Part B, it says ethanol 2-carbon aldehyde is heated under reflux with acidified potassium dichromate 6. So this is the oxidation and it is under reflux, so it will go to carboxylic acid. So ethanol is 2-carbon aldehyde, CH3, C double bond OH. This is oxidized in the presence of oxidizing agent. So the product formed is carboxylic acid. We have 2-carbon aldehyde, so it will form 2-carbon carboxylic acid. Now this is neither a secondary alcohol nor aldehyde or ketone, so it will not give the product. Part C, methyl ethanoate, which is an ester. In ethanoate we have 2 carbons, in methyl we have just 1 carbon. It is heated under reflux with dilute sulfuric acid. So acid hydrolysis of ester takes place. So ethanoate is the one having 2 carbons, CH3, C double bond O. And methyl means we have just one CH3 present on this side. So this is methyl ethanoate structure. Now upon acid hydrolysis, what will happen? This bond is going to get broken. We have 2 carbon carboxylic acid and 1 carbon alcohol that is formed. So CH3, COOH and CH3OH. Both are not fulfilling our requirement for positive yellow precipitate, so therefore this is also incorrect. Now last one. We have propanol, which is aldehyde, 3-carbon aldehyde, CH3, CH2, C double bond OH. Is reacted with NaBH4, which is a powerful reducing agent, so it can reduce aldehyde back to primary alcohol, CH3, CH2, OH. So we can see a primary alcohol is formed, and it is not similar to this one because we need a secondary alcohol having CH3. So again this is incorrect. So the only correct option is then A. Question 35. The skeletal formula of M is shown. This is the skeletal formula. M is reacted with an excess of LiAlH4. Dilute acid is then added. What is the molecular formula of the final organic product? So let's see what functional groups do we have here. We have a carboxylic acid functional group. We have an alcohol and an aldehyde because a hydrogen atom is still present here. So LiAlH4 is powerful reducing agent. It can reduce carboxylic acids. It can also reduce aldehydes. So carboxylic acid is reduced to primary alcohol. Aldehyde is also reduced to primary alcohol, while secondary alcohol is not affected. So the products would be like this. Instead of COOH and CHO, we have 2 primary alcohols. So now the structure will be like this: CH2, this is CH2, this one is CH, OH is still present, then we have a CH2 again and CH2OH. This will be the product that is formed. Now let's find the molecular formula. We have 5 carbons, 12 hydrogens, 3 oxygen atoms. So correct answer seems to be D. Question number 36. Which compound forms a precipitate when mixed with 2,4-D-NPH and also forms a precipitate when mixed with Fehlen's reagent? Now 2,4-D-NPH, it can form a precipitate with aldehyde as well as ketone, while Fehlen's reagent can only form precipitate with aldehyde, not with ketone. So an aldehyde must be present in both, or a ketone and an aldehyde. So let's see, part A, we have different functional groups. This one is alkene, this one is a ketone. Again we have CH2 on this side, so this is alkene. In second one we can see we have aldehyde. And we have alcohol that is attached to carbon, having 3 carbon atoms directly attached, so it is tertiary alcohol. In next one we have alkene, and this is C double bond O, which is ester. In this one we have a ketone, alkene, again an ester. So what we need is aldehyde. So we have an aldehyde in part B, so therefore part B will give a precipitate with Fehlen's reagent. It will also give a precipitate with 2,4-D-NPH. So correct answer should be B. Question 37. Which reaction is a redox reaction? Redox reaction is the one in which both oxidation and reduction takes place. First part is ethane nitrile that is heated under reflux with dilute hydrochloric acid. So ethane nitrile is the one having 2 carbon atoms and a nitrogen atom. So we have CH3CN. In the presence of dilute hydrochloric acid, it converts to carboxylic acid, which is CH3COOH, and ammonium salt. If it is HCl, then it will be ammonium chloride. Now we can see we have carbons and hydrogen. The oxidation state of carbon and hydrogen does not change when they are bonded to each other. H plus is still H plus, COO negative. There is no change in oxidation. We can see there is no redox reaction in first one. We have ethanoic acid, which is 2 carbon carboxylic acid reacted with sodium hydroxide. So this one is a neutralization reaction. So ethanoic acid is CH3COOH, NaOH. So it will form a salt, CH3COONA, along with water. Oxidation state of oxygen is still -2. COO is -1. Sodium is +1. So it is also not a redox. Let's look at part C. We have ethanoic acid reaction with sodium. Again 2 carbon carboxylic acid. Sodium metal. Now acid plus metal, it forms salt and releases hydrogen gas. So we have CH3COONA, that is salt, along with hydrogen H2. Now if we look at the oxidation states, we can see COO is negative, H is positive, sodium is neutral as it is element. Now Na becomes +1, COO is still negative, hydrogen in the form of molecule is 0. So hydrogen goes from +1 to 0. So this is reduction. While sodium goes from 0 to +1, which is oxidation. So both oxidation and reduction are taking place. So therefore C could be correct answer. Part D, ethyl ethanoate is heated under reflux with dilute hydrochloric acid. Now this is ester. We have 2 carbon on one side, CH3, C double bond O. We have 2 carbons as it is ethyl on the other side, so CH2, CH3. Heated under reflux means that this ester is going to get broken down. This carbon oxygen bond will be broken and it will form carboxylic acid and an alcohol. So CH3, COOH and alcohol. Now carbon and hydrogen are bonded to each other, so there is no change in oxidation states. And alcohol, we can see O is negative, H is positive, H is still positive. So there is no redox reaction taking place. So the only one in which redox occurred is part C. Question 38. Ethyl butanoate is a flavoring with fruity flavor. Which row is correct? Alcohol and acid that react to form ethyl butanoate. We have to find out the reactants. The mass of water formed when 2.32 grams of ester is formed. Let's draw the structure of ethyl butanoate. Ethyl means we have 2 carbons. Butanoate means we have 4 carbons. So 1, 2, 3 and 4. And then we have 2 for ethyl part. 1, 2. So the reactant that is involved in order to make this compound should be like this. This part comes from acid, this part comes from alcohol. So we have 4 carbon carboxylic acid. So it should be CH3, CH2, CH2, COOH and 2 carbon alcohol, CH3, CH2, OH. So 4 carbon carboxylic acid and 2 carbon alcohol. We have 1, 2, 3, 4, 2, 1, 2, 3, 4, 2. So it could be A, it could be B. In C and D, we have 2 carbon carboxylic acid, which is wrong. Okay, now let's look at the mass of water formed when 2.32 grams of ester is formed. So whenever 1 molecule or 1 mole of this carboxylic acid it reacts with 1 mole of alcohol, what happens? And this hydrogen and this OH, it forms water molecule. So the second product that is present is H2O. Now the molar ratio is 1. We have 1 mole of carboxylic acid, 1 mole of alcohol. It forms 1 mole of ester along with 1 mole of water. So they have given the mass of ester. Let's find the molecular formula and then we can find out the number of moles. So this ester, it contains 1, 2, 3, 4, 5, 6 carbons. We have C6, 12 hydrogens, 2 oxygen atoms, and we have H2O. Let's find the molecular mass. We have 6 carbons, so 12 into 6 is 72, plus 12 hydrogens, plus 2 oxygen, which is 32, and water is 2 plus 16, which is 18. So this comes equal to 116. Now let's find out the number of moles from this given mass. So we have 2.32 grams of esters. So number of moles is equal to mass in grams divided by mR. So 2.32 grams divided by 116, it gives 0.02 moles. Now from balanced equation, we know it is always 1:1. 1 mole of ester is formed along with 1 mole of water. So if the ratio is same, then number of moles should be same. So if 0.02 moles of ester is formed, it means 0.02 moles of water should be formed. But they want to ask about the mass of water, so let's convert this moles of water into mass. So mass equals moles into mR. So moles is 0.02, mR of water is 18, so 18 into 2 is 36, so it is 0.36 grams. Correct answer is therefore A. Question 39. Cyclohexene as shown in the diagram can form an addition polymer. Now this is cyclohexene. We have double bond between these two carbons. Which structure represents a section of the polymer? Now always remember that on the backbone of this polymer, we have only those carbons that are making a double bond. So these two carbon atoms should be present in the backbone of that polymer, while these carbons should not be present as a backbone. So let's suppose if I draw it like this, we have 1, then we have 2, and so on. So double bond is converted into single bond and a new bond is formed on each side. One bond here, one bond here, one bond here, one bond here. So it will be attached like this, that these two carbons will only be a part of the backbone. So let's see which structure is correct. In part A, they have given 1, 2, 3, 4 carbons as the backbone, which is incorrect because for one molecule it should be 2 carbons. In part B, they have given 1, 2, 3 carbons as the backbone of each molecule. Again, this is incorrect. Then on C, it starts from here, 1, 2. So 2 carbons on backbone of one molecule, 1, 2. 2 carbons on the backbone of second molecule. So C seems to be correct one. In D, there is 1, 2, 3, 4, 5, 6, 7 carbons on the backbone, which is not possible. So correct answer is only C. Question number 40. 3 organic compounds are listed. We have ethanol, propane 1-ol, propane 2-ol. Which compounds will have a mass spectrum that contains a fragment peak at mass to charge ratio of 43? Now what happens in mass spectrum is that different bonds can be broken and there is a loss of electrons. So we can find out the mass to charge ratio. First one is ethanol. Ethanol is the one having 2 carbon atoms. So we have CH3, C double bond OH. Now let's find out the molecular masses of different sections. For carbon and hydrogen, we have 12 plus 3, it is 15. For this carbon, it is 12. For this oxygen, it is 16. For this hydrogen, it is 1. So let's see whether it makes 43 or not. So 15 plus 12 is 27. 27 plus 16 is 43. So yes, if this bond is broken and we have a positive charge, then the mass to charge ratio is 43. 15 plus 12 plus 16. So it will be like this. We have CH3, C double bond O, and the charge will be positive in mass spectrometer. So this will give a peak at 43. Second one is propane 1-ol. Let's draw the structure of this one. Propane means we have 3 carbons, 1, 2, 3. And on first carbon we have OH group also present. So let's do the same. We have carbon and 3 hydrogen, so it is 15. This one is 14, this one is 14, 16 and 1. So let's see if it can make 43. 15 plus 14 is 29. 29 plus 14 is 43. So yes, if this bond is broken, then we have a product CH3, CH2, CH2. And if charge is positive, it can be observed in mass spectrometer with a molecular mass of 43. Then we have propane 2-ol, 3 carbons with OH on second carbon. So in this one we have a carbon and 3 hydrogens, so it is 15 on this side, 15 on this side. This one is 13, a 16 and a 1. So let's see if we can make 43. 16 and 1, 17, 20, 30, 40, 45, 15, 18, 28, 33, 43. So if we do these three, we break this bond. We have 15 plus 13 plus 15, so it is 30 plus 13, which is 43. So CH3, CH, CH3 can be positive and it will be equal to 43. So all three can give a fragment peak at 43. So correct answer is then D. Thanks for watching. If this was useful, please do like, subscribe and share.